Good afternoon. Host for this program, Creactive. I like to brief about Creactive. Creactive is a group of people who are like-minded and curious to gain new knowledge. Cre means creativity, active means activeness. To be active, we need creativity. Knowledge Square is our tagline. Sharing of knowledge increases our knowledge. Vision of Creactive is to build constructive thinking on various domains. Our main focus on non-textual, non-academic, non-syllabus related concepts. Every Saturday, we organize online weekend talks on the Zoom platform and we live stream our program on our YouTube channel, Creactive GBD. Creactive is thankful to all our resource persons for engaging us with their knowledge. Today, Creactive talk on Chandrayaan-3 Indian visit to the lunar South Pole. This achievement stands as a testament to the dedication, expertise, effort of the talented team at ISRO. This unwavering commitment to advancing our understanding of space has brought us closer to unraveling the mystery of our celestial neighbors. Let's take a moment to express our sincere appreciation for the Chandrayaan-3 team, extraordinary accomplishment and their contribution to pushing the boundaries of space exploration. Today, we have Mr. Ashish Devraj to present the session. He completed his bachelor degree in the National Institute of Technology at Calicut, Masters in Indian Institute of Space Science and Technology in Thiruvananthapuram, and now he pursuing his doctoral research at Christ University, Bangalore, on exploring composition of lunar surface and surface boundary exosphere using Chandrayaan-2 and ground-based observation. And he published several papers and also he presented in several conferences. Please join me in extending a warm welcome to Mr. Ashish Devraj sir, and also I welcome all the participants for joining us today. Over to Ashish sir.
Thank you so much for the invitation. Hopefully my video is visible to all of you.
Yes, sir.
I'll start with sharing the presentation. My screen is also visible, right, to everyone?
Yes, sir.
Okay. So first of all, thank you so much for inviting me to give a talk on Chandrayaan-3. You know, right, like the Chandrayaan-3 is the most prestigious thing which is happening in India now, right now. And ISRO had done a lot of things to send Chandrayaan-3 after the landing failure of Chandrayaan-2, and we finally succeeded in landing on the moon. And India, and making India the first country ever to visit the South Pole of the moon. So I think being a person working on the lunar science and also using the data from Chandrayaan-2 orbiter, and I'm greatly pleasured in talking about Chandrayaan-3, which is a which is a much promising thing, which maybe we all can work on later from the data from Chandrayaan. So I'll start off with something which we all are very familiar with. So then I'll go on to tell about why it is important to go to the South Pole, and then how and also what all are we planning to do with Chandrayaan-2 using the instruments en route. So as you can see in this slide, you are very familiar with these three images, right? The first one, the green colorish, this part is a river. from the surface of the Earth. And the side and on the right side you can see glaciers, the ice form of the of water, and also the broad and extensively large oceans of the Earth. So Earth is actually covered with a lot of water. We have a lot of water on the surface of the Earth, and we have the various cycles of water, which is happening, which takes water from one place to another, and which takes in, I mean, which converts all the water into different forms, like different states of water, like ice, the liquid form, and also the gaseous form. So this cycle is very familiar to all of us, right? Because we all studied this during our preschool, probably during our LKG, somewhere. I mean, not in LKG, probably on an earlier classes. And we all know, like, in this water cycle which happens in Earth. So I'll just briefly mention what it is, and the major sources of water, or major cycles of water which is happening on Earth. So let's first look at the left side of the split. uh, uh, this is the ocean part, and the sun, the energy coming from the sun will evaporate the water from the ocean and bring it to the atmosphere of the Earth, and which then condenses and form clouds, which you all see in the sky. And then once the cloud moves towards the land, and it cools down, precipitation happens, and rain falls down. And again, as surface flows, the water reaches back the ocean. That is the right part of this image. And the left, sorry, the left part of the image. On the right side of the image, you see the snowfalls. I mean, the water on the mountains of Earth as a form of ice. This is not only found in the mountains of the Earth. We also see them at the polar regions of the Earth, as Antarctica and Arctic regions. So these ice also melt and form river-like structure rivers, and that also reaches back to the ocean, which is again then transported by evaporation and precipitation and all that. And these cycles are happening always on Earth. Okay, so this is a very familiar thing for us, right? We all live in this planet, and uh, this is what is happening, and which is I mean, which is sustaining life on Earth, and all those things which you see on Earth is happening because of these water cycles. So I'll now take you to something, some kind of a different place, and this is the surface of the moon, which was mapped by LRO. There is a mission called as LRO by NASA, and they have mapped or imaged the moon at different. The entire moon is known to us in terms of surface geology and all that. Still, there are a lot of things to be studied. That is always there. And when you look at these images, do you find some kind of a water presence in them? And it always looks very dry, right? It's all dry. You don't have greenery anywhere. You don't find any speck of life or something like that. Uh, uh, on a broader view, broader sense, when you look at these images, this is one of the image taken by an astronaut which went on the Apollo missions. And here also you see a very dry landscape by visually looking at it. But this is and also one thing to notice is the sky, which is very dark, which does not have the blue color which you see in Earth, because the moon does not hold an atmosphere. I would say a thick atmosphere, because there are presence of a very tenuous atmosphere which I am studying about. So so we don't see a lot of optical phenomena which you see on Earth, because it doesn't have a uh, thick atmosphere, and that's the reason why the sky is also black in color. So I want to emphasize on this point that the surface which you see is very dry, and also uh, since there is no atmosphere, there is no cloud formation, there is no possibility of precipitation and all that. So is that actually true? uh, that's what we all thought that it was very dry, and until and unless we thought we had some detections of water from Chandrayaan-1 mission. There was a payload called as Moon Mineralogy Mapper on Chandrayaan-1, which was sent in 2008, and then we actually detected the presence of hydroxyl groups and also water on the surface of the moon. So this is something similar, not similar. This slide shows the water cycle which happens on the surface of the moon, which is actually very different from what you expect. I mean, what you see on Earth and all, because of all the dry conditions which I have told of. So let's first look at the sources of water on the moon. So basically, as we see on Earth, also we had some kind of volcanic activity in the early history of the moon, uh, around like a b around like 1 billion years ago. And those volcanic activities, the basaltic material or the material coming out of the volcanoes had water content that reached the surface as thick, I mean, on the surface as the basalt spread across the lunar surface. And that is one source. The second one is the comets and asteroids, which always keeps bombarding on the surface of the moon. And the third one is the interplanetary dust particles and very small micrometeorites which found on the surface. Those all those sources bring in water to the surface of the moon. And for example, let's assume that a volcanic eruption happened at the equatorial region of the moon, and then how does it get transported into different regions of the moon? It's a volcanic activity can be at a localized place, right? So for that transport, what the temperature driven migrations happen, like you know that the surface of the moon is having extreme temperature conditions. The lowest temperature is around minus 200 degrees, 250 degrees Celsius, and the highest temperature goes up to plus 150 degrees Celsius or more. So uh, so that huge range of temperatures causes the water, higher temperature side of the spectrum, causes the water molecules to get released from the surface and then hop, as it is shown here. It has some kind of a hopping mechanism which happens. The temperature releases the water molecules, and the gravity takes it and puts it on a different place on the surface. Similarly, during the day and night cycle, this hopping happens, and once the molecules keep moving and then reaches a place where there is no temperature variation, or it has a very low temperature, then it cannot escape anymore, because there is the higher temperature portion is not happening, right? Those regions are called as the cold traps, which is shown on the right side of the figure. So these cold traps are there where on the surface of the moon, where there is no light, the solar light reaching, because the sun is influencing the temperature variations, right? On the day side you have 150 degrees Celsius, and on the night side you have minus 200 degrees Celsius, something like that. Though, so if the solar radiation is not reaching some portions of the moon, some particular portions of the moon, then what happens is we don't have a temperature variation. We have the most uh, coldest regions of the solar system present at those regions. So those are called as the cold traps. And you might that those regions, the cold traps, are actually found on the surface, the south pole of the moon. So as you can see this animation on the right side, there are many craters and everything around. This is the south pole of the moon, and there are many craters around. And as you can see, this is the shadow caused by the sun as it moves around in orbit. So you can see that some craters does not receive light at all. So those regions are called the permanently shadowed region. So since there is no light coming in, the temperatures there is so low, and it goes up to -1 to 250 degrees Celsius. So once water molecules, or some water molecules which was there at higher latitudinal regions of the moon, reaches this permanently shadowed region, it cannot escape anymore, because the temperatures there are so cold that it cannot get released to the to do that hopping mechanism which is happening on the moon. So that is it. So the water presence which was detected by Chandrayaan-1 on the south pole of the moon was actually transported due to all these processes. And this is actually a hypothesized thing, and it was transported to the permanently shadowed region where we detected water. So that is the reason, one of the reason why we want to go to the moon's south pole, because you see you have detected the presence of water at the south pole region, and in greater quantities. These are all initial measurements which was happened by various instruments which was sent to the moon prior to Chandrayaan-3. We want to know more about how much water is present, and can we, how is the atmosphere there? Can we take in people there and go to these South Polar regions and make permanent settlements there, so that we can do experiments and all that. So the thing is, if you are planning for uh, uh, a longer duration trips to the moon, I mean, to do some scientific experiments and all that, you need to take in resources from the moon itself, because you cannot take oxygen for a month of time, or even more than that, and take it there and use it there and come back again. So it will be always good if you can take out resources like water and oxygen from the lunar surface itself. And since we have detected more water in the south polar region, it is always preferable to go and see whether the detections are always right, and we can quantify how much water is there and all that, so that we can utilize them for later purposes. So there is one other reasons also to go to the south polar region. These maps show the mineralogy, which is minerals which are present at the south polar region. So I want you to look at this topology map first. You can see the topology means the height of the surface from a mean or mean surface position. So the red portions in this figure is showing the higher grounds, and the blue portion is the lower grounds. And you can see that a large region is shown as blue color in the south polar region. That is called as the South Pole Aitken Basin. That is one of the largest basin which is detected on the surface of the moon, and that happened during a collision which happened in the Great Bombardment period of the moon's evolution. So this crater, or this large basin, once it was formed, it excavated a lot of material from the mantle region of the moon, and then it was distributed around in the south polar region. So, so that makes the South Polar region rich with minerals, which is not seen in many places of the world. So, as you can see, there is thorium, titanium, and other mafic materials like iron, and pyroxene compositions, which is like magnesium minerals or calcium minerals. So all these elements which I talked about, like thorium, titanium, iron, and pyroxene, the magnesium, and all that, are actually very useful material if you want to build some settlements there. For example, iron can be used to make rods or whatever structures which you want. So if you it is very important to know what minerals are there present in the South Polar region if you are going there, and so that we can extract out iron or magnesium to do some experiments or make settlements, make building structures and all that. So that is it. So that's the importance of South Pole, because you see a lot of minerals and you have a lot of abundance of water also. So we this is one of the slides which shows all the lunar missions which has already gone to the moon. So all of them have gone to the near side of the moon, which you see, the black region, which you see in the sky. So we have sent around 21 probes to the moon, and we have landed at different locations on the moon. But as you can see, most of the landings have happened at the equatorial region or near to the equatorial region of the moon. So slightly higher latitudes. But as you can see, towards the South Pole, we don't have any of the missions which have been gone. So, and being such an important place on the moon, South Pole should be explored, right? That's why we had sent uh, the Chandrayaan-3 mission towards the South Pole. And a lot of other missions are also getting lined up by NASA and JAXA. There are many other missions which are targeting the South Pole, and we are the first one to reach there. This is where we have gone, and this is the South Pole, the image of the South Pole of the image, South Pole of the moon, and the permanently shadowed regions are here, and you can see a lot of craters, which is cratering events which has happened on the South Pole of the moon. So when you choose such a region that to land on, and we can study what all minerals and all those things are there on the surface. So that is, and you might all have seen. So I was very happy to see all these images once it came out. So the left image is the landing site taken from the lander of the of Chandrayaan-3, and you can see all the small craters which are found on the moon, and all the lunar soil which is present there. So and on the right side you have the rover which is about to come out of the lander, and then which rammed down and reached to the surface of the moon. So talk now. I'll bring you to the different parts which was sent to the moon, all the payloads which was sent to the moon. The first of all, let me take you to the broader things. First, we had a propulsion module which and a lander on top of the propulsion module, which was launched by the LVM-3 rockets to the lower Earth orbits of the moon. And then this propulsion module had enough fuel to do a lot of orbital maneuvers around Earth, and also take the lunar transfer orbit and reach the moon and do a lot of maneuvers on the at the lunar orbits also. So the propulsion module was the part of Chandrayaan-3 which took the lander to the South Pole of the moon. So it had and as compared to Chandrayaan-2, Chandrayaan-2 was not only having a propulsion module, it had all the science instruments attached to the orbiter satellite, and those things are actually observing the lunar surface till date. So it is continuously observing the lunar surface. So and now coming to the lander part, it is actually designed to land on the soft land on the surface and work for almost like 14 Earth days, which is one lunar day, and we were successful in landing the lander on the surface of the moon. So, and the third part is the rover, which is again, which was housed inside the landers. And once the lander landed, the ramp came out of one of the sides of the lander, and then the rover came out of it. And rover roved down to the lunar surface. So, and we had multiple instruments. We had 5 instruments on board of Chandrayaan-3 lander, and no, on lander and the rover. So on the lander there were 3 instruments. One is called as the Lunar probe, the Ramba LP probe. The second one is Chaste, and the third one is ILSA. The first one is the probe is actually designed to measure the plasma atmosphere, which is plasma region around just above the surface of the moon, at the vicinity of the lander. So the plasma is actually coming from the solar region, solar wind and all that. So we need to know what the plasma density is. That plasma contains charged particles, charged electrons, maybe some atoms, charge ions, and all that. So if this is very important, because if you are sending some human beings to the South Pole, and if we should know how the atmosphere is, and of that region, what is the particle densities there, what all particles we can expect, and such things can be measured using the Lagman probe. The second one is the Chaste. Chaste is actually a drill kind of structure, which will be drilled down to around 10 centimeters in the surface of the moon, and then we measure the temperature profile. How does the temperature vary at a different point of the surface, like how does the temperature vary between the surface of the moon and slightly interior of the moon, which is just 10 centimeter. I should mention that. So that is also a very important thing if you want to extract out minerals, or something like that. You need to know the temperature profiles of the surface. And the third one is called as the ILSA probe, which is actually, you all know about the earthquakes which happens on the earth, right? So these are seismic waves which is traveling around the surface of the moon, surface of the earth, and which causes the surface to move. So not of the scale of earth, but moon also shows some seismic activity which is generated underneath, in the inner portions of the moon, and which travels through the crust of the moon, and which can be detected, and it was already detected by various Apollo mission instruments, surface instruments. So this seismic activity, ILSA, is actually designed to detect such signals of the movements of the seismic waves, which is traveling through the crust of the moon. So why do we want to measure that? So as you know, we all know that, like, the earth has a core and a mantle and a crust. Like, the interior of the planets are actually studied. So how do you study this? So if you want to know what the interior is, we need to look at these seismic waves. The seismic waves act differently at different layers of the moon, so that and we can kind of probe at what depth the core is, or what material it is made of, and how is the mantle region. Is it molten? Is it having what kind of uh, uh, what temperatures it might have? So these are all done using simulations. So ILSA can measure such seismic activities, and then the data coming from ILSA can be used for simulations, which can be used to understand the mantle and crust of the moon. Also basically the interior of the moon. So now coming to the rover. Rover had 2 simple instruments. not simple instruments, I would say, but those two instruments were designed to study the minerals and also the atoms or the chemical composition of the surface. So the first one is called as APEX, alpha particle X-ray spectrometer. So which is working based on a principle called as X-ray fluorescence. So what it does is it generates alpha particles from the instrument, and that alpha particles will interact with the material on the surface, and which will cause X-ray fluorescence, which will emit the atoms will emit X-rays. X-rays as fluorescent X-rays, and that can be detected by the instrument, and so that we can know what element is present on the surface of the moon. So that is APEX, APXs. And the second one is called as the LIBS, the laser-induced breakdown spectroscope, which has a powerful laser, and which the laser will be fired onto the surface of the moon and to create plumes. Which is actually burning the lunar material and then creating plumes, and then that is spectroscopically studied to understand what elements are there and what kind of minerals are there on the surface of the moon. So basically, the rover can move around, right? It will move around 100 to 200 meters, which is within the very vicinity of the lander, and then we can sample different regions of that places which the lander, the rover moves, and get the composition of the moon and what kind of minerals are present on the lunar surface. That is, as I mentioned earlier, those measurements are very important because we need to know what minerals can be extracted from the surface of the moon, so that we can use that for later lunar missions, which is planned. So, and this is one of the very other interesting thing, which is this is actually not about the moon. Uh, 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 Chandrayaan-3, the propulsion module of Chandrayaan-3 actually carried an instrument called as SHAPE. As you all know, that Earth is the only known planet only planet which we know that hosts life, right? So if you and we are all in a search for to answer the question: Are there life? Is there life elsewhere in the universe, somewhere else, in some around some other stars, and some other planets going around the star? So first of all, if you want to look for life signatures, you should know what signatures life makes, right? So as you know, as Earth being the only planet which we know, and it will be a curious thing to observe Earth and look for biosignatures, right? Or signatures which life can form make around Earth, which can be detected. So, being at a distant point like the moon, like 300,000 kilometers away from the Earth, and there is the SHAPE payload, the spectropolarimetry of habitable planet Earth, is actually looking at Earth and to look for spectropolarimetric signatures, which might be caused by the life forms or whatever we don't know what we are going to find out, but still that is a very interesting thing to look at. And we can once you find out some signatures from shape, we can use those signatures and look for those signatures on exoplanetary systems which is farther away from us, which we cannot go and probe as of our limited technology till date. So this will be a very interesting thing, which I am also very keenly interested in, because I am very curious about the data look like. So now coming to the latest updates from Chandrayaan-3. So now as you all read on in the news that the rover is ramped down and started and reached the surface. And the recent update from ISRO on its Twitter page showed that the rover covered around 8 meters, moved around 8 meters near the landing site, and also all the all the payloads, the 5 payloads which I mentioned, are turned on and they are all working properly as expected. So we hopefully will have many results, or the data coming start coming out from these payloads, and we'll definitely record them and keep them. And the work comes after this. Actually, for scientists like us, we uh, we want the data and we want to look into what is there. And this is it will be very exciting if once the data comes and to scientists analyze them. So we only have limited time since the lunar day, as lunar night is like 9 or 10 days away from us. So all these things will be kind of a very a fast days, so that we will go and study the surface using all the instruments which we have. So I don't want to uh, forget mentioning about Chandrayaan-2, because Chandrayaan-2 had helped a lot in the landing of Chandrayaan-3. And this is one of the image which was released by ISRO, which is an image which was imaged by a high resolution camera on board the Chandrayaan-2 orbiter. And that orbiter is that imager is actually the highest resolution. Its capability of having generating high resolution images. It can 1 pixel in that image is actually 30 centimeter cross 30 centimeter. And so you can imagine the amount of resolution which you have of the surface of the moon. And those information that images were used to study the landing area, which was selected for the landing of the Chandrayaan-2. And we also knew where the hazards were, where you have craters, where you have big boulders or rocks kind of structures. So Chandrayaan-3 knew everything because of the earlier its predecessor Chandrayaan-2. So I should say that the Chandrayaan-2 is still active, and we are taking a lot of data. I am using Chandrayaan-2 data extensively. There's an instrument called as class on board Chandrayaan-2, which is actually a remote sensing version of APXS. APXS is, as I mentioned, it's working on the basics based on the principle called as XRF, right? So the Chandrayaan, the class instrument is also working on the based on the principle called as XRF, and that is actually remotely mapping the composition of the moon. So there are a lot of results which have came out from class and other Chandrayaan-2 payloads. So with that, I will leave you there. Chandrayaan-3 is already on the surface of the moon, and we are expecting a lot of good data coming in, and let's see how it goes. And thank you so much for your time, and we are on the moon, and we'll see. Yeah, I'm also very curious and how the things will go about. So that's it from my side. And I'm looking for questions.
Thank you, sir. Any questions? If you have any questions, you can ask the questions. Venkat, you have any questions you want to talk with Ashish, sir? 1 minute. Yes, Ash. Venkat, you can.
Good afternoon, sir. Thank
Hi,
you
Venkat.
for your wonderful talk. That was indeed a great one. So I meant to ask you a question. So here you were presenting about some systems of Chandrayaan-2, sorry, Chandrayaan-3, right?
Yeah.
So
Yeah.
my
The
question,
payload song. Yeah.
yeah.
Please go ahead. Not able to hear.
Yeah, you said something.
Please go ahead with your question.
Oh, okay. So I was saying that this configuration has our different systems of communication, right? So we have used different communication systems, the high gain and low gain antenna, as we know. So I wanted to know that what type of bands and systems have we been using for this system, using for this,
Okay.
using for the rover lander.
Okay, okay. I'm actually not an expert in that particular region because the antenna communication all comes from with an engineering side. But I can try to attempt it because there are some there are the high gain antennas, and I think it is working in the S band and um, P band. I'm not very sure about that because
It's
uh,
uh,
so I'm not very sure about that because that is not looked up about how the
so
communication is happening.
that
Yeah,
means that it's a low band communication system.
probably yes. It
Okay.
actually has two ways of communicating. One directly to communicating with the deep space network in the ISRO has directly sending commands to the Earth itself. The other one we can the lander can communicate to the satellite which is orbiting around, and that satellite can send information to Earth and to Earth. That happens. That's what I know about that. I'm sorry that I can not able to say your question completely.
Okay.
I can check it and get back to you immediately.
Sure. And just second question on over here.
Okay.
We have seen this mission life expected for 14 days,
Yeah.
like 14 Earth days
Yes.
or one lunar day. So basically, from what we know, our plan is that we'll land on the moon. There will be one day, lunar day, that will be spent. After that, the system will be shut off as we'll be on the night side and the moon will be cold,
Yeah.
cold in temperature. So my question was that we don't have any heating units, like unlike other spacecrafts, like accounting to Russia and Luna 25. We don't have any heating units in the spacecraft. So it's just one lunar day that we can finish our research. So what's the likelihood of it outbeating its own life expectancy?
Okay. That's a very a good question, which maybe we'll have to leave it to chance because we don't have any heating mechanisms on the lander. So once the lunar night comes in, the temperature drops to around minus 200 degrees Celsius also. So withstanding the electronics, withstanding that kind of a temperature is actually not very much predictable, right? It might most probably fail if the during the next day site comes when the next lunar day starts, we can try to switch on all these instruments and see whether some of them are working or not, because this is purely we can only leave it to chance because we don't have any heating mechanisms there.
But anything that can be done is pretty limited over here, right?
Well,
After let's say it even survives.
if it survives, we can do all these experiments again, right? We can take out more data points. For example, let's assume that the ILSA payload survives the cold night, and so we can get more and more seismic activities, which we can pick up more and more seismic activities from the lunar surface, which as and when you get more and more data, the modeling and everything which we can do with that data becomes much more precise and accurate. So that is the thing. It is all chance, because since we don't have a radiator or a heating mechanism, if some of the instruments survive, we'll get more data. That is actually a plus point if we get more data.
Okay.
Any more questions?
Not from me.
Okay. Any more questions?
Yes.
Sir, just tell me what your research is going on, and is there any projects regarding Chandrayaan-3? You are working in that or what?
Uh, as of now, Chandrayaan-3 has just landed and we are acquiring the data. Later, at some point, maybe we can think about how to work with those data and connect it with the science which I do. So what I am basically doing is I'm studying the surface composition using the class instrument, which I mentioned during the talk, which is on board the Chandrayaan-2 mission. So that we are mapping the surface composition, like detecting elements like oxygen, magnesium, aluminum, silicon, iron, manganese, titanium, kind of. So all those rock forming elements are being detected using class. So that is the surface part. And I'm also looking at the atmosphere. As I mentioned earlier, the moon has a very thin atmosphere, which is actually very similar to the exosphere of the Earth, exosphere of the Earth. So that I'm probing the atmosphere using ground-based telescopes and trying to draw relationships. I mean, the draw connections between the surface and the exosphere of the Earth. So later at some point, maybe since Ramba, the LP probe is looking at the plasma atmosphere, and all that, I'm not sure. This is not yet planned or anything like that. So probably we can look into the data and see how since how the plasma atmosphere is influencing the elements to really get released from the surface and reach the exosphere. So some studies in that direction can be done. So that is just a thought which came to me. So that it has to be discussed and further checked how the feasibility will work.
Okay, there is one other question. Raghavan sir, you can ask the question.
Some studies in that
Good evening, ma'am.
Okay.
This is Meghna from
Okay.
Raghavan
Ma.
School.
Yes, you can ask, ma.
That question is, how does the rover works by its own, or is there any control of scientists, ma'am?
Raghavan sir.
Control of science instrument. I don't.
Good evening, ma'am.
The echo is coming backside. Okay. We are unable to
Can you please
listen.
repeat the question? I did not get it completely. So,
That question is, how does the rover works?
okay. Okay. Rover works in terms of the movement.
Don't
Are you talking about? So in the case of the rover, it is actually powered by its own power sources, and we can give commands to the lander, and lander will be communicating to the rover, which will we can decide which way to go, turn, and all that. So that is actually controlled by the people sitting on Earth, and we are based on the terrain which you are seeing, and it also has some cameras on board the road, so we know we can see where it is. If there are some hazards in front of it, we can turn and we can go for different reasons. And also based on the chemical composition, which remotely sensed chemical compositions which we know, we can drive to those regions and then look for composition if possible. So those are all controlled by the people sitting around. Those things can be controlled by people sitting around.
Okay.
Hopefully, I answered your question. That's what I think.
Sir, your voice is little bit dull.
My voice?
Yes, sir. Little
Oh,
bit. And one thing, sir, for future researcher, what is your suggestions regarding this field? What you are working now? How they have to enter and what exams they have to qualify, and just give me how you entered this university and how you related to ISRO. What type of connection between Christ and ISRO? You are doing some work, no? Just brief me, sir.
okay. So, and the thing is, basically, I am actually from an astronomy background, astronomy, astrophysics background. I did my master's in astronomy and astrophysics. So I was interested in this, and we have basically how people come to this field is through BSc, MSc, and um, doing various research projects under ISRO probably. And they also have JRF positions, which where you can join and can work um, on various science projects. So basically, and there are multiple ways to go. I did BTech and then I did my master's in astronomy and then worked in Indian Institute of Astrophysics for some time and then explored various areas in astrophysics. And I was interested in planetary science because this is something which we can look at, right? We can go and sample. For example, Chandrayaan-3 is on the surface of the moon, and we are able to study it in very close detail. So such kind of things were very interesting for me from my childhood. So this was personally for me, it was like that. And and the amount of data which we have for example, in the case of class itself, you have years of data, 3 or 4 years of data. You have a lot of lunar sample which was returned by the Apollo missions. Apollo missions actually returned around 400 kilograms of data. I mean, lunar sample, and only the half of it is still analyzed. So another 200 kilograms is still there. And if you can go up with a lot of science goals in mind, you can actually use those samples and do all sort of research possible. So which is actually a very interesting field. And also recently there are a lot of lander missions which is lined up in the next 2 or 3 years, and many countries are going to the moon. So the inflow of data will be more in the coming years, and I see a bright future and a lot of opportunity in the lunar community which is coming. So, and also regarding my project, the ISRO actually calls for AO proposals. It's called as announcement of opportunity proposals, and the universities, the professors in the universities can put in science proposals to ISRO so that ISRO can fund their projects. So here I'm working under Dr. Srija Skatta from Christ University, and also my co-supervisor is Shyama Narendran from ISRO. And both of them and the team here in Christ, including Blessing Matthew and our professor Paul Keating, they all came up with a proposal and they submitted to the ISRO, and they got funding from ISRO. So that is such projects are happening around India. So I was fortunate enough to come and join the project and later continue my research on these doses. So that's how just how I came into this project.
Shama Narendran ma'am is working on X-rays, right, sir? Moon
Yeah.
X-rays.
Yeah, she is working on XRF, especially the class instrument, and she's also part of various instruments, and also Chandrayaan-3 other payloads, which is instruments which is under development in ISRO. So she is mostly into this X-ray part of the spectrum, and that's where we are working. Our project is based on.
That's nice. Long way.
It's actually a long way because a
Mm.
lot of things are, the data is there and we need people to look into the data and come up with all sort of science which can be done with the data. So it's actually we have a lot of opportunity. We need to find out and apply for the correct things.
But people these days are more inspiring about technical courses, sir. They are inspiring and get into that courses. That's why the researchers are very less now. Deep into research field, we can count less number of people we are seeing now. That's the
Is that a trend in the
yes, sir. Yes,
universities?
sir.
But yeah, I don't know about the general thing in India, but still, I feel that there are a lot of research happening. I think the limelight is
Ah,
not here. The limelight
mm,
is over to the technical side. So the
yes,
landing part, see, that was a huge achievement, right? A lot of
mm,
technical stuff happened, and the media coverage and the limelight was there. We have a lot of research happening in India, which is I think which is uh, not reaching the broader community as the landing did. So once if you, the people like you who are bringing in science to the public, uh, is actually doing that, right? I mean, trying to bring in all the research which is happening and
yes,
putting it
yes.
and showing it to the public. This is actually very important because
Mm,
people should know what is happening and what all opportunities are there. And understanding the moon itself is, it's very
mm,
fascinating, right? You see all the moon always, and if you know what that black patch is, you feel that's where uh, a lot of curiosity is there. You understand?
yes, researchers usually that field, no, sir, that curious the researchers usually. That's why they stay longer time over there.
Yeah, we leave the lab very late.
Yes.
Yeah.
Yes. Any more questions? Okay. Okay, sir. It's already 4. Uh, shall we end? Any more questions? I'm unmuting. You can unmute and you can ask the questions. Okay. 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 I think no more questions. Thank you, Ashish sir, for your Venkat.
Yeah, I just
Yes.
came across like hearing to all the answers.
Uh-huh.
Just had another like added question.
Yes, tell me.
System, I think, just wanted to know that what is the, you can say, uh, what is the type of uh, things we can, what are the types of, maybe we can say, research that we can keep as part of record. So we have currently signed multiple treaties in terms of space. So according to which, what should be the, you can say, likelihood of some type of, you can say, base or something worked by the Indians on this landing area that we have found. So some type of base that is maybe signed by multiple nations, and maybe we can use it for some sort of activities to travel to other planets or etc.
Are you asking how the results from Chandrayaan-3 will help other missions? Is that what you meant?
In short, yes.
Yeah, okay. So, as I mentioned earlier, South Pole is a very interesting region and a lot of missions. And you might have read about Artemis mission, right? NASA is going back to the moon and we are planning to put human beings on the surface of the moon again. So they're all planning for the South Polar region because of the resources there, especially water and all the other mafic minerals resources present there, and such kind of things. So we still have uh, um, we don't have in situ measurements of all these quantities, like how much water is there in this permanently shadowed region, and how much oxygen can be extracted from the lunar surface, and how much oxygen is there, or how much iron is there. Such kind of questions are still to be answered uh, with in situ missions. So only we had orbiters around, and we have a picture of the lunar south pole. And let's see, for example, in the case of class, and since I'm working on class, I can comment on them. So the pixel which it maps is 12.5 kilometer across, 12.5 kilometer across. That is the highest resolution which is ever sent to the moon. But that you assume that when you calculate the area, that's a huge area, right? When you compare. So you need to know what actually the soil is. It's always good. All these geologists always say that it's always good to go and test the material by their hand. So something like that is happening with Chandrayaan-3. So we have a rover kind of geologist there, and it's going and looking for all the materials there, what is there, how much, what chemicals in there, such we can put constraints on all those materials. So that data can be later used for all the other missions following. So maybe when you are planning, if you are planning to put a permanent settlement there, if you know how much water is present, and we can plan accordingly, right? Or how to extract it, how much water will we get from the regolith if you do this process or that process. So such kind of various kind of things can be done using this data.
Got
So
it.
that's how this data will help the future missions.
Okay. And I think it's a lot likely for other missions to join Chandrayaan-3 as well.
Yeah, other mission. See, we had 5 instruments on them. So this is not the only thing which we can do at the circle.
Right.
So other missions can have different kind of payloads, and they can measure different aspects of the circle.
Yeah.
Right. So
And,
everything contributes.
yeah.
That's right.
And it will come from whatever shared research of
Definitely.
with
Yeah,
Chandrayaan-3
definitely.
as well.
Yeah. Actually, the Chandrayaan-3 data will be public after uh, um, a proprietary period which is there. I think initial calibration and all those things has to be done by the instrument teams, right? So I don't know exactly the period, but it is around 6 months, I think. After that, the data will be released to the public, and anyone in the world can use this data and do science with that or computer physics.
Got it. Okay, thank you.
Ashish, sir, thank
Yeah.
you very much for your time and your contribution to Creactive. We are very much happy with your presentation. Thank you one and all for joining with us. Thank you.